and then so on and so forth. Next one. Now, if we were to combine our knowledge of messages and queues together, we'll be able to come up with a definition like so. We'll be able to come up with the idea that messaging queues are some form of asynchronous process that allow us to communicate in between our services or in between processes. So we have a producer sending a message to the queue and the consumer receiving the message. So the producers and consumers can be two separate web servers or two separate parts of the same web server, like we'll demo in today's meeting. And the process is simple. Messages go off of a queue. Sorry, messages go off of a process into a queue, and then the consumers can pull whatever data they have. So, like if we were to use the example of our YouTube analogy, if we were to use the example of our YouTube analogy, all of the separate servers or services, the compress service, the file formatting service, and then all of the other ones, we could set it up so that they could all be able to process messages from the queues without needing asynchronously, without needing each successive one to be done. So they could all pull, or we could set it so that only one consumer could pull. And then today, as we go on, as either of us explain or introduce you to the Azure Service Bus, we'll explain the difference between topics and queues, or we'll explain the difference between topics and queues. Next slide. Exactly. The concept of messaging queues or message queues can be split into two separate designs, basically. So you can have a point-to-point system like the one I just described, where it's going from one end to the other end. So it's going from one producer to one consumer, meaning once the message leaves the queue, it is off the queue entirely. So no other person can access that message because it has been done. If the message fails, it can be dequeued or requeued, sorry. But once the message leaves the point-to-point system, it can be accessed again. And then with the publish-subscribe model, like the picture or the diagram we have here, once the message goes, you can go into all of the different services we have set up. So just like we also explained, the compress service, the refactoring service, and any other additional service or the thumbnail generation service. So the main difference between the point-to-point system and the publish-subscribe system or style of messaging queues is that with the point-to-point one, it only goes from one producer to one consumer, or with the publish-subscribe method, it can go from one to a plethora of consumers and vice versa. So with the publish-subscribe one, data can flow both ways bidirectionally. With the point-to-point one, the typical architectural design for it is it only goes in one direction. Great. Can we go to the next one? Exactly. So now that we have, I feel like I'm going too quickly. I've already gone like 3-4 slides in like 5 minutes. Just let me know if I'm going too quickly or if you need me to re-explain something, and then we can just do that. If there's anything you're not understanding, then just raise your hand and then ask. But just to continue, what type of scenarios would be good to adopt messaging queues? So we have three major processes. We have the indeterministic processes. These are basically idempotent processes. So processes that can't fail. So like examples listed here, right? Since these have ways, sending out emails through SMTP, and then using any form of third-party service that you're not sure is super reliable. So if you're teaching that, take users info and confidence to like using things like this, onboarding flow again. But if we were to up to the queue or the messaging queue, this queue is even if the SMTP portion of the email sending out portion of our process fails, you can just done again, we can still grant the user access. Then it'll be good to take it off bed and then send that message secure. Swap, the user can go on with the flow, and then I'll let the user them, okay, this process has been done. And then another good example of when we can use messaging queues are with long-running processes. So if it's a batch process data, like say, you had this, and then during the daytime, we get too many requests. So it takes a long time to process. If there's any scenario during your whole process where you think maybe the user doesn't need to wait for this to happen, or maybe the user doesn't, type of scenario can always be put on a messaging queue. Next slide. Next slide, please. Hello, can you hear me? I don't know if it's still on. So while we're waiting, if anybody has any questions about anything I've said now, maybe clarification or clarity, you can just ask. Even if the question is asking me to repeat certain things over or re-explain certain things, feel free to ask, just so everybody fully understands the concept of messaging queues. Can we move on to the next slide?
Hello, can you hear me? Hello?
Yeah.
Hello, can you hear me? Oh my God. Hello?
I can actually hear you.
Oh,
Like,
God.
I don't know about the host.
Oh, shit. Yeah, I guess I was muted since and I thought I was talking. Yeah, someone was asking me that. Audrey, you were asking a question or something.
Yes, 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 I can hear you.
Did you have a question? Who was speaking? Was it
My
Audrey?
God, what is this? Yes, yes. Can you hear me?
I can hear you. Please go on.
Okay, so there was a previous slide before this last one. Then after the asking questions, I wanted to ask about that last sentence where you said basically when a user, that line. I just want to understand like what does it mean? Maybe
Which
could
of
you
them?
add
This
it,
one?
like,
This
with
one?
yes, yes. In short,
Or the
anytime you
left?
think, like, yes,
Oh, yeah.
just explain the last line.
Dibri, you can.
Oh,
Dibri, did
so
you get our question?
sure. Sorry, can you guys hear me? Yes, I heard that. Can you guys hear me?
Yeah, can hear
I
you.
need
Go on.
something you guys can hear me. One. Let me try to switch to. Hello, guys. Can you guys hear me? Somebody
Yeah, I
just
can
let
hear
me
you.
know.
Yes, I can hear you.
Okay,
Can hear you. Go
great.
on.
So what I'm saying is, during this, what I'm saying is, any point in our entire flow or in our, if we're building a product first service, see something that uh, that's for the general public that users will use. Any point in our app flow where we think maybe the user doesn't need to be waiting for this, for their process to be completed, then we can put it on the queue. Like say we were doing I mean, some of these things come with the downside. But say we're doing a finance or fintech style app where we needed to maybe that's even overbuilt. Just simple processes. If we know if we know uh,
I don't know. Your voice is breaking. I can't really get everything.
Yeah, Dibri, your
let
voice
me
is breaking. And maybe you
let me
can
try.
change location.
Yeah, let me do that. Let me do that. 5 seconds.
Yeah, Audrey, let me just add something there. So, like the previous example Dibri gave, where he said when you're uploading a YouTube video, I don't know that you were there when he's mentioned it. So,
No.
yeah, so like, okay, when you're uploading a YouTube video, you don't go watching, waiting for the video to. You can do that. You can like be watching and waiting for the video to upload completely so you can share with your friends. But you don't necessarily have to do that. You can just upload and go do something else. Maybe go take your bath or
Oh,
go and cook beans. Right. So it doesn't require your immediate feedback, your immediate action, any immediate action from you. It's something that takes a lot of time. So it's something we want to do in the background. So we would want to like queue it up, want to like send it to a queue so that it can happen and we'll go do our business. Right.
okay.
So
Thank you very much. Thank you. I get
yeah,
it now.
yep. Are there any other questions or do we move on? Okay, guess there's none. So, Dibri, I think this was the last slide we were on before the question. So you can continue from here. Dibri, are you there? Hello. Okay, I think after this slide, I'm meant to give I'm going to give a demo of the microservices approach, right? So I'm just going to continue from here. Can you guys confirm you can hear me properly?
Yeah, I can hear you properly.
Thank
Can
you.
hear
Sorry,
you.
I have a question.
Okay,
Hello.
Dibri, you see there?
Hello.
Yeah, is the audio any better?
No, I can hear you now.
Okay, I said I have a question. Can I go on?
Please go on.
Okay, so my question is for the message queue system, for it to work, does it have to be in a microservice architecture or a monolithic architecture?
Okay.
Okay, that's a good question. First, let me finish my answer for Audrey's question, and then I'll answer yours. So like I was saying for Audrey, just like with our YouTube analogy, when the user uploads a video, they don't need to be there to wait for every single process to be done. They don't need to wait for us to generate thumbnails in different file formats. They don't need to wait for us to reformat that video to work for 244p or 360p or any of that. They don't need to wait for that. All they just want to do is to upload that video and know that the video is live. That's all the user really wants to do. So putting that on the same thread as upload creates a big disservice for our user. So anytime there's a system like that, then it may be smart or it may be a good idea to upload that and then send all of that data to a queue so it can be processed in the back end, and then we can receive a notification when it's done so that the user knows, yes, this thing has been done. So we can send email notifications, or we can even have a live chat.
Okay, thank you. I get it now. Thank you.
And then for the new question, okay. And I don't know who asked that other question. I don't know. Can you say your name?
Victor.
Okay. The concept of messaging queues is architecture agnostic. So it can be applied to microservices or monoliths or single apps. So it doesn't really matter what service you're using. The same concept can be applied. And then during the demos, Austin will take a microservice approach and then show us a demo related to that. And then I'll show us monoliths. Hope that answers your question too.
Yeah, it does. Thank you.
Then can we move on to the next slide so we can hurry up and then so that you can.
Yeah, I think this was the next slide, or was it this one?
Yes, this is it. So now that we've gone through what messaging queues are, the how they can be implemented or the types, it'd be good to know the why or what benefits can come of adopting this type of architecture or concept or architecture. So one of the benefits is scalability. Like in the publish subscribe model I showed to you, you can have a service send a message to multiple or every single service that wants it. So scalability or adding or increasing app functions is a benefit of adopting messaging queues. Another one would be load management. Like I gave in one of the other examples or analogies, when we have data spikes, that's not overwhelm our service. You can be sending or offloading certain data, I think, and offload some of the stress on our whatever computing service we're using by sending some of that data to the messaging queue and having the messaging queue process and send it to where it can be processed. Another one will be increased uptime. Because we're doing all of these things, because of all of these other benefits that can come with it, it means our service is up and active more times than it would not have. The added benefit of being on our service or using our service. Okay. Order completion. Another great benefit of the queue is depending on how you set it or how you set up your queue or what application system you use, we can choose to requeue failed processes. So if something fails, we can just send it back to the back of the queue and have it processed again. So then we can put a limit onto how many times that can happen before we count it as a failed process. So sorry, I don't know what's happening. So if we were to do, again with the video analogy, if some part of the process or the thumbnail generation failed, we could just send that portion of the message back to the queue and wait for thumbnail generation server to be free, and then we send it back to it, and then we can regenerate the thumbnails and send it out. So we can move on.
Right.
We can move on.
Yep.
So with Azure Service Bus is Azure's offering of queuing systems in general. So it has two types, basically. It offers two types of queues, the topics and the queues. The queues refer to like the one-to-one, end-to-end, point-to-point side systems we described earlier, and the topics just refer to pub subsystems or public subscribe systems. The next I'll hand over to Osinachi to carry on with the rest of the presentation.
All right. So I'm meant to do a demo, and hopefully the gods of demo will be fair with me today. Okay, so I'm just going to get started. Yeah, that wasn't it. Okay, so before we get started, I'm talking about messaging queue or message queues in a microservices architecture or approach, right? I'm going to be very interactive. Sometimes I'm going to switch to Excalibur. I'll be on the slides, right? So first, let's talk about microservices. So the normal way we learn how to develop apps or how to build systems is we write some code, right? Apologies for the dog in the background. The dog in the background. So the normal way we do stuff is that we write code and we upload the code to some server. Like, okay, assuming it's a front-end app, we upload it to something like Vessel, right? And the app gets accessed via a URL to our users, right? That's like a direct way to do things. Like it's so straight. You write your code, you deploy your code, you give it to your users. But when we are dealing with thousands or millions of users in a distributed system, or like just millions of users, you can't usually use that because you can't use one server. Right? You can't use one server to serve your app. You would be looking at using multiple servers. And when you bring multiple servers, a lot of things go wrong. So that's why the microservices architecture was even developed. It was developed to solve the issue of having multiple servers running our applications, because it's not so easy to sync the states of different applications running in of the same application running in different servers. It's not an easy task. Right, so okay, this is just a sample diagram I got from Nginx website. Nginx is a web server company kind of thing, right? So microservices can usually are just apps, tiny apps that have their own database and expose some kind of endpoints. So it could be like a UI, it could be a web UI, or it could be a REST API. So let's look at this. So we have these different hexagons, right? We have driver, trip management, notification, payments, driver management, passenger, and all these things. So these are the services in our big application, right? And they expose different things. This one has a UI and has a REST API. Exposes a REST API, which is connected to other services. right? So this approach of building services is not ideal. Let me just put a simpler example. So you have a web interface and we have 3 services here: product, orders, and shipping, and they all have REST APIs. So what happens when, say, the order service goes down? Because that's very possible. Say you deployed the product service in the US and you maybe a data center in the US, and you deployed the order service in Europe and the shipping service in South Africa. And somehow something happens to the data center in Europe. So what happens to your users? What if somebody's making one critical payment, maybe that his babe has been asking him for weeks? that is like the thing that will make or break their relationship. Don't mind me, please. So we don't want our users to lose connection or when our services go down, right? So if this service goes down, that means we can't start shipping products anymore. We can't ship products anymore because it's all tightly coupled. So the whole idea of queues in microservices approach is to decouple our systems and also buffer decoupling mainly. So we want a situation where we don't use REST APIs directly, but we just use the queues basically. So say a new product is added to the store, right? Or a user selects a product and adds it to his cart. So he sends the application, like the web interface, sends a message, just like Dibri said. It's just a message is just like a byte string or byte array. You can see it as JSON, right? And just go to my browser or VS Code. This could be a message. Right? This is just JSON, right? We have or something like this, something as basic as this, body, maybe the product name, say iPhone 13. This could be a message. It's just a JSON string, right? Usually it's formatted as bytes, right? So let me go back. So it sends messages, and the other service receives the message. So when a message is sent, the queue, so this like just see this as a queue, will send an acknowledgement that it has received a message. So once it sends once it acknowledges it, we now know that we have placed the order or something, right? It goes to the order service, maybe does some processing, calculates the price, and sends a message to the shipping service so that the item you're buying can be shipped, right? So in this approach, if the order service goes down like before, if you watch closely, you see that the product service can still be sending messages to the queue, and the shipping service can process all the messages in its queue while the other service is down. So these two services keep working while the other service is down, right? So initially this one had like 5 messages, but now it has, say, 8. Is this 8 or 9? Right, so it just keeps adding messages to the queue, and the messages are just very small, so we won't worry about our queue filling up, right? Because it just see it as a file that things just get added to the end, right? Like a log file, right? So this so when the other service gets back up, it can continue processing messages and sending it to the appropriate services connected to it. So in this case, we won't have that issue where we had REST APIs and we couldn't do anything because one service was down, right? Then just go over this. So I'm going to talk about Azure Service Bus, but I'm just going to tell you about other queues that you can use, right? So there's Kafka, there's RabbitMQ, there's ActiveMQ, If you're an AWS person, there's Amazon SQS, simple queue service. And for Azure, for the Azure folks, although you should not choose one cloud provider, use all of them. For the Azure folks, you can use Azure Bus Service. Azure has other things for message queues, right? Not just Bus Service, but Bus Service is, I think it's the one with the most use cases, and it's quite easy to use. So I feel like I've been talking too much. Does anybody have any question at this point? And what this small slides demo I just did? No question.
I have a question. Can you hear me?
Please go on.
Hello, can you hear me?
Yeah, I can hear you.
Okay, so the question I have is, you say that if one server goes down, that it will affect other servers. The reason being that
Yeah.
there are messages in the queue, but
Mhm.
so what if the server is down and all the messages in the queue are exhausted, that have been processed? If another person sends a message, will it go through?
Okay, let me see if I can go back. Okay, so you said if a server is down, like say the other service is down, right? And all these messages are processed. Is that what you're saying?
Yes.
So there's no
Oh,
longer any. If there's no longer anything, nothing will happen now. Like, okay, wait. Okay, let's go to Excalibur so that we can visualize what you're saying. Oh, this is my browser. Let me just get this. Okay, you said so this service is down, right? So which one is which queue has finished? Which queue doesn't have messages again? Is it this one or this one?
product service.
Okay, so this queue no longer has messages, right?
Yeah.
So let me delete. So all the messages are finished. So what's your question at this point?
Okay, so if anyone passes in an information to the product server now, what will happen?
A new message will come now.
Oh, and it will not be affected that other service is down.
Okay, yeah. So now if someone passes a new, okay, let's say everything here has been exhausted, right? Yeah, I think I get what you're saying now. And somebody now sends a new message, right? It just comes and stops here. It just stops because it can't go here, right? But other things can still be happening, and we know that eventually the thing is going to be processed, right? So we won't worry too much. And even in the real world scenario, you won't even notice, right? You might just see that the site takes more time to load, but you will not necessarily have to place your order again, right? So, so that's yes. Does that answer your question?
Yes, something like
Like,
that.
can I ask a question?
Yeah, go on.
So my question goes like this: when you have a queuing system, for some reasons your server goes down,
Okay.
and your server is down, and you have messages in your queue. When the server comes up, does it automatically, sync with the queue? How do you handle such connections with the queue and the new server that is actually being spin up?
Okay, you mean spinning up a new server.
Yeah.
Right. So the queuing system usually has a pointer to where the last processed message was read from. So there are like different ways people do it. Some people, after processing a message, they delete it completely from the queue. Right. Some other people will just move the pointer backwards. Right. Okay. Let me go back to my code editor. So I'll show you something. Right, let's look at these line numbers, right? Assuming, no, this is not a good example. Let's say we have Q dot TXT or something like that. So visualize this as a queue, and we have messages, right? So we have, and the messages are just products. So we have iPhone 13, we have MacBook Pro 2018. What else? We have Casio calculator.
Yes,
So we have these three things, right? And let me just add more things so that we can have more things to work with. What else do people buy?
Xbox.
Xbox, right? Okay, so let's see this. I forgot text files or not. I wanted to use this debug feature. Okay, so this will work. Just going to add this in string. Okay. So let's say it was reading messages, right? It's read this, then it stopped here and the server went down, right? So this will be the pointer. And when the server goes back up, it now gets the pointer from the queue and continuous processing. So it goes and stops here. So that's how usually those are the two ways it goes. Some people when for maybe another scenario, you could have it this way where you process okay, it comes like this, right? Yeah, it comes like this. So say the flow is this way. So the messages are coming from top to bottom. So when they process the Xbox order, pop it off. Process the headphones order, pop it off, pop, and the queue is empty. So that's another. Those are the two approaches. Right. So where were we safe? Okay, he's asking me that anybody has any question. Are there more questions before we move on?
Hello, can you hear me?
Yeah.
Okay, there was something you said, like when you were presenting, you said when the messages are queued up, let's say there were 9, and then the server is down, that messages are still moving.
Mhm.
And then I'm not trying to understand the last thing you said now, that when the server is up, it goes back to the last message with the pointer and starts, I don't know the English to use, and starts again. So I'm trying to understand, okay, what are the messages moving? Because at the initial stage, when the server was down, messages were moving. So when the server is up, which message is moving again? That's what I
Okay.
want to understand.
I think it's the whole idea, and I brought the two approaches that confused you. Okay, so the purpose of these messages in our queues are not just for just keeping them there or for storing them, right? It's for them to be processed. A message has a purpose, has an intent. Um, it could be an order you placed in an e-commerce store, right? So that your order, maybe you must calculate, say, the shipping details, the shipping price, or the product's price, right? So that's what message contains information that gives these servers the ability to do this computation on the things we do within the system, right? So it's the processing now that we're talking about. So the different ways different message queues handle processing. Some will, something like Kafka now. I think from what I've done on Kafka so far, people they don't usually pop off messages from Kafka queues. They just use that pointer approach, right? So instead of you deleting messages, you might want to use those messages to do something else later. So you want to delete them. So you use something like a pointer. So that pointer moves down. Go back to this place. So it moves down. It moves down based on the last messages it reads. So this is how they come in. First, someone placed iPhone 13 order. Another person placed Mac Pro 2018 order. Someone else placed this calculator order. And that's how it goes, right? So as these orders are coming, as they are coming like this, the queue is processing them. So the queue is going to be processing them. I don't know how to do this in art, text art. So the queue is, yeah. You want to like explain better to us?
While using pointer, I just want to get clarified. Is it you delete your messages within that queue,
Yes.
within that pipeline?
So
while
when
you're
you're
using pointer,
when you're using pointer, you don't. That's why you're using the pointer. You don't delete the messages, right? You just want to point to the message to the last place you stopped processing. Maybe here. Maybe here you stop processing here, and you want to continue now. You resume from here, and you go down. Then you go down. Then you go down. Sorry. And you stop at the end, right? You stop at the end. So when new messages come, we stop here, right? It now starts, now continues, and continues, and continues. You grab.
yes, I grab. Thank you very much.
Audrey, do you understand now? Don't know whether I even said something reasonable.
You did
Or did I
not
confuse you more?
complete my own. I started asking something else. You can
Yeah,
go back.
I thought the two questions were like related.
Tell me.
Sorry,
Yeah.
Andre, I don't know. I think I from the question you asked initially, I was able to get or retrieve the idea about the question of you wanted to know the difference between the pointer and actually popping off messages from the queue. So the one in the pointer doesn't delete your messages; it actually stores them. So at any point, your breaker or your pointer stops. Maybe for instance, your server is down for some reasons, for numerous of reasons. Your server is down. It automatically stays there till when your server pops on. So you can, because the message, you actually send a message, you must get a response. So if that server that is meant to respond to that message is down, your message cannot be processed. So that is why it stops there till when the server comes on, then it continues within that queue. So it's just a different service isolated to make your system reliable.
Oh, okay. Thank you. I get it now.
All right. Awesome. Thank you. Who was speaking?
That's Dozier.
Okay, thank you, Dozier. My boss. Okay, so any other questions or should we continue? I have just, my demo is very small and I have an extended example here. Can I just go over the extended example? Just go directly from Excalibur. All right, so please, nobody should judge my UI skills. I'm terrible. Okay, so this is just a sample system where you mostly just use queues to connect the different services, and each of the boxes you can think of them like microservices or front-end UIs, right? So not doing anything specific here. I'm just showing a very rough architecture. So the purpose of this system is for you to calculate. It's just like the pricing part of an e-commerce store where you can calculate the price of your goods, apply coupons, and calculate the price of your shipping or the shipping costs, right? So this is the flow. If I go down, this is the flow. It goes this way, then goes down, then goes down, and it stops here. So let me just go zoom in a bit. So let's say this is the sample e-commerce store, and you have done your whole adding to carts and stuff, and you click purchase now or something. So it takes you to the place where you input your shipping details, right? So you put your street address, phone number, email, and stuff, and click enter. So now it sends that message, right, to the shipping queue, right? So we want the shipping details you just entered to be processed in our shipping service, which is just like an app or a function or something. So like a serverless function or an app that will calculate the shipping based on your location. So that's that's what happens here. When it calculates does its computation and gets the price of your shipping, it sends to the price breakdown. So this is where the e-commerce store will show you how much you're meant to pay for. The product price is already there. They just now add the shipping price, right? So the product price was like $100 and your shipping is $20, right? So the total is $120. So if you do have a coupon that can give you a discount and you do enter the coupon in this box, right? Apply the coupon, it sends the data to the coupon queue, right? So coupon queues, the message flows to the coupon service. So the coupon service is similar to the shipping cost service, where it calculates your discount based on the product or the coupon code. I think both, anyone, just depends on what you want to implement. All right. So once it has gotten the data, it has gotten the discount, it sends it back to the pricing page. So now the pricing page will display your discount and show you the total amount you're going to pay. All right. So now that you've done that, you can now click order now, right? And it sends your order details to the payment service, right? So on the payment service, it's most likely going to redirect you to an external service that where you process your payments, like maybe a PayPal, Pay Now page, or the one familiar to us is Flutterwave or Paystack integration page where it shows you bank transfer, card payment, and the rest. Or some companies like Konga, Konga has their own payment service. I guess I don't know what they use under the hood, but they have their own stuff. Most people will give you different options, sure. So once you've made your payment and it's successful, now the external payment service is going to maybe send a webhook notification to your own payment service. So your own payment service now is going to send a message that your payment was successful. So at this point, we have a pop sub. All this while we have been having the point-to-point approach where we have a UI talking to a service or two services talking to each other, right? One point to another point. At this point, we have pop sub where we have one service, one queue publishing to different receivers, right? So this your UI, your web UI is subscribed to the queue, and maybe your email service is also subscribed to the queue. So that one message comes here and splits up into the two services. And once it does split up, you receive an email that your order was successful, and you also see it on the page, right? Ideally, this is how things are meant to go. So it doesn't stop here. I mean, it could continue. Maybe we even have things in between that checks whether your order is looking fraudulent or not. So we have things like fraud detection or anomaly detection and stuff. But this is just a basic architecture, right? And while I wanted to implement this architecture, I did not finish up. So I did something simpler, right? Okay, I'm just going to open this. So I did it on GitHub. Right, so I have a GitHub repo that contains a little demo. So I'm just going to show you sending and receiving of messages. So on Service Bus. But before we go to this, I'm just going to go to my Azure portal and should tell you about Service Bus. So like Dibri mentioned earlier, Azure Service Bus is a cloud messaging offering by Microsoft, right? By Azure, sorry, not Microsoft, Microsoft Azure. So it allows you to do your messaging thing in the cloud. If you were doing it yourself, you probably do it using something like RabbitMQ locally. Maybe maybe you're deploying to production, you would set up a server where you put RabbitMQ. But other things is stress. You can just come directly to Azure portal, right? Then create a resource, just search for Service Bus. And you should be able to find it. Right, so you basically just create a new service bus and impute your resource group, location, pricing tier, right? And namespace too, and create it. So I've already created one earlier, so I'll go to that one in a bit. But if you're new to Azure, I'm just going to give you 1 minute explanation. Azure is basically a cloud service provider. So it gives you a way to deploy different things to the cloud. Say you're working on machine learning, you can train and deploy your machine learning models on Azure. If you're deploying a website that's going to be used by thousands of people, you can do all that within Azure. If you're deploying a Kubernetes cluster to do auto scaling and stuff on your containers, you can do that on Azure. Even if you're creating a simple static website that has your portfolio, you can do that on Azure too. So Azure gives you a lot of services, and if you have GitHub Students Pack, you can get, I think, $200 from there, or $100, can't remember. And if you're also a student ambassador, you can also get $150 credits. So we might talk about Azure more. Let me just go fast because we're running out of time. So just going to go to all resources and find the, okay, so this is the queue I deployed earlier. So we go to this entities part, you can see queues, right? And we won't be doing much on topics today, do more of queues. So I have 2 queues here. I'm just going to focus on this one, CAT products. So this queue is the queue I created to handle the little demo I have on Gitboard here. Right, so that's it. So on Gitboard here, what I basically did was copied code from documentation. Right, so the idea is that you have messages. These messages are probably produced by your application, by your front end, and sent to your back end. Right, and but here is just in an array, and you have the queue you're connecting to, in this case, CAT products. Then you have, in this place, we used batch processing. So as your messages come, you could like save them in an array, then have a scheduler that runs in your app that processes them in maybe 5-minute intervals. Right, so here we just have a simple for loop that adds messages to the batch queue, the batch queue within your app. I shouldn't be using queue again. Adds it to the batch, let's say a batch buffer within your app then sends the messages, right? And once the messages are sent, they're sent to the queue, and any receiver that is connected to that queue will receive the message. So this is not really a code demo, so I won't be looking too much at the code. I'm just going to run the code so that you see the output. So first, I'm going to run the receive code so that it can be running before we send the data to the queue. Okay, I already had some things in the queue, right? So it just received the messages that were already there. And if I do run the send code, am I getting this error? Let me copy this. Try again. Then let me run to zero again. So when I run the send code, it sends the messages to the queue. Let me run it again and see. It sends the messages and this one receives the messages. So as we keep running it, it keeps sending and receiving. So the idea is that this queue doesn't just connect your app like that. Usually you have like a cron job running within your server that can run periodically, pick up messages from the queue, process them, and send them to maybe another queue, right? So that's just a very simple example of how do you do queues. So this manual thing, I came here to my terminal to type in the commands. These functions that are run will be something that will be run by your scheduler running locally to pick up your messages and stuff. Right. So on the queue within Azure, you can't really see the messages, or maybe there's a way to find where you can actually see the statistics of your messages. Right, so we have 9 messages active. I think we just sent 9 messages recently. Let me send another to see how it's. Let's refresh this. Okay, so we just sent 3 messages now. We have the queue responding accordingly. So you could go ahead and have fun with maybe trying to implement this service. Don't have to build the whole UI, just doing it locally. And I'm just going to mention this. Azure gives you another beautiful thing, right? It's, Azure services are so connected. So you can actually read messages from a queue from function app, the serverless function. So I was trying to do that here. So I created the functions app, right? And have this function that reads from the queue, right? So the trigger type is service bus trigger. So once new things enter the queue, the function app will run and do some processing. So we can actually implement this system we set up using functions alone if we want to. So these different things, these different services can just be functions connected that run whenever new messages are added to the queue. And so basically we could do that. So this is basically my own demo. Debris can go on, but does anybody have any question at this point?
Okay, so the only question I have, hello, can you hear me?
Yeah, I hear you.
Okay, the only question I have is recently I read about Redis, and Redis does have a mechanism that supports pub and sub message and queue, just as you have explained. So the question I have is, does Azure also have Redis database on their system. I'm not used to Azure at all.
Okay, yeah, Azure has a Redis service, so you can just
So instead
type.
of me to go, okay, sorry,
Well,
because
the
I know when I
Azure,
was reading to your code, I
Hmm?
noticed you kind of hello, can you hear me?
Yeah, yeah.
Yeah, I was reading through your code when you were doing the demo. So I like the first two lines you imported the particular database. You call it service bus or something. I don't know.
Yeah, okay, so I'm
Yeah,
using the Node.js clients here. So we have to use the Node.js, the npm package that can connect to Azure Service Bus.
yeah, I noticed that. So but instead of me to do this, I could also use Redis. If how do I go about it using Redis on Azure platform? Is it the same
Do
procedure?
you want to use Redis local? Okay, you want to use it on Azure, right? And you want to use it within your application. Abi?
I didn't get that. What do you say?
You would want like your implementation is that you're going to be deploying Redis on Azure, then you'll be using it within your app, right? You'll be connecting
Yes.
to Redis from your app. Yeah, so it's the only difference between maybe I think you must have used Redis locally, right?
Yes, I have.
Yeah, so the only difference is that the connection string will be different. So instead of you putting local host, you're going to put some Azure URL that's where an instance of Redis is running. Yeah, so it's same thing. And yeah, you can also use Redis as a message, as a queue. You can use it as a queue or a cache. Different things you can do with Redis. I guess that's where you're coming from, right?
Yeah. Thank you.
Okay. All right. You're welcome. Any other questions for me before Dibri does his demo?
For that question, I just came to understanding why I get my alerts late, my Access Bank alerts late, because probably for some reason the service that actually sends alerts is down, and so it remains in the queue to when it comes up, then they send me my alert maybe like later on in the day. As I can
Yeah.
this one.
Yeah. That's actually that's probably true. I don't know how they implement their stuff, but most probably. So, any other questions? Kind of running late. Dibri, were you sharing?
yeah, am I still sharing?
I can't see your screen.
Where, I'd
Okay, I can see
initially
it now.
set up,
I can see it now.
I'd initially set up the service so that everybody will be able to try out the onboarding flow on their own. But this evening, Azure decided, I don't know, something broke in the code, so it's not working right now. So I'll just do a local demo with somebody's details. So if you want to volunteer, you can just put your name and email, first name and last name and email in the chat, and then we'll send a demo with your details. If you want to volunteer, just do that while I describe what the demo will be. So I tried to replicate an onboarding flow. So the user sign up form. So the user sends in, submits their name, email, and then on the back end, we collect the email and then send the confirmation to them to say, thank you for joining our service and all of that. This is another good use case for using queues in processes, not like Osinachi's microservice approach, but using it in processing. This way, even if the email service sending it through SMTP fails, it just gets put back into the queue and then it will happen eventually, you feel me? And then the user can still get on to use the service. I can't see the chat because of this. So. The word Ocean actually dropped his thing, so we'll use his name and email, and then when he gets the email, he should just let us know.
Oh, wait. Is it one volunteer?
Yeah, just one
Sorry,
volunteer.
don't use my details. Use Olivia. Olivia was typing. Olivia, why did you stop typing? Don't mind me, please. Go on. Okay, yeah.
Okay, let's wait for her. So I built this with Jane Golang. So, and then I'm using Redis for in-memory persisting for the data. And then, okay, great. The data is here. Let me just. Under pressure, bro. Fingers crossed, and hope it doesn't leak on us now. But Olivia, just let us know when you do get an email. Maybe you can share your screen and share what the email looks like, or you can just send us verbal confirmation of email going on. It's rather than expected. Yeah, well, let's try that again on the next day. Sorry, the app stopped running, so I have to. Does anybody have any suggestion of what we can be doing while we're waiting for the service to spin up? Okay, guys.
Yeah, maybe folks can just explain, they share experiences where they have used queues and how to use them and stuff.
Great. If you're watching and you do have an experience of using message queues, you can come on and share while our service is going. And then when Olivia does get the message, she'll just let us know. This is weird.
Hello, can anyone hear me?
Yes, boss.
Yeah.
I think the problem is coming from my internet. So just give me like 5 seconds and then I'll.
All right. So for queues, when you talk about queues, mostly just have to look at it as the name implies. People standing in a queue in a bank. So there was this application that I and my friend worked on. So we wanted to be able to search through YouTube videos using the words, the transcribed words, that is the captions, the subtitle of the video. So we discovered that YouTube doesn't have like a public API for that. So we decided to use a hack. And the hack was basically having Puppeteer in the backend server. And what Puppeteer does is that it opens the URL of the video, YouTube video in the backend. and uses the Puppeteer's API to capture the caption of the video running in the backend. But then the problem that we had in running this is that it was processor intensive. So let's say, for instance, you have like 3 users trying to use our application and get the caption of the video simultaneously, of different videos simultaneously. The server was basically a Heroku server, probably 512 MB of RAM, and the server couldn't process all these requests. So we decided to use, although we didn't use Azure Service Bus, we made use of Redux and one unpopular. No, I don't know if it's popular. We actually saw it due to the need of needing something quick. One, I think Booton. I think that was the name of the queue service connected with Redux. So we use that to queue the request. So what happens is that if you have about 3 or 5 users trying to get the subtitle, trying to search user service to find out where that word was said in the video, to queue the request and send you an acknowledgement to the client that your browser telling you, hold on a little bit, we are trying to retrieve the caption and search through the video. So that was my own experience.
Yeah, that was a great experience. I think I remember when you guys were demoing this stuff. You never really think of this backend components that you use within large systems until you try to design a large system yourself and see how slow it is. Yeah. So does anybody have any other example of use case? None. No. Dibri, how is it going on your end? Can you guys hear me? Hello. Can anyone hear me? Hello.
I can hear you.
Okay. Dibri, are you still there?
Yeah, sorry. I think it worked when Samson was sharing his experience. I think the problem was, the Redis server I spun locally had gone off, so I had to start up again. But it had gone to, so you can see we were able to directly go into Olivia's feed, quote unquote. Now we're setting that the email has gone into the messaging queue, and at some point the confirmation email will be sent out. Hopefully she's got it by now, because there should be nothing holding out. So Olivia, if you got it, just tell us if you got it.
I've not gotten
And then
refresh your email.
yeah, I've done
And then-
like several times.
meanwhile, I'll just, the code is live, so if you want to go to it, I'll share the link in the chat so that you can go to it. Maybe, I don't know why you don't want to do that, but
Maybe you send us thank you for attending using our emails. You guys can drop your emails to the chat. I want to receive a message.
Great. Yeah, if you do want to do that, then you can drop your name and email, and then I'll just run everything locally.
Thank you, guys. I think that would be it. That's it. Thank you all for attending. Jose, you're okay. Yeah. Thank you all for attending. It was great having you all on this one. And thank you for listening to our flaky explanations. All right, so I think we should be ending now. Anyone has any other question, can reach out individually, connect with.
Yeah, and please, if you do want to, if you're interested in databases or if you're interested in databases and you do want to host an event related to that, just DM me and then we can figure something out. Thank you.
All right.
Much. That's all I have to say.
Can we drop
Yeah,
our handles in the chat so we could connect to each other?
Yes, for sure.
Yeah, I didn't see yours in that chain. Although I'm following you on Twitter anyways, but I still want to see yours.
I don't know. I didn't have time to put socials. But yeah, I'm just going to share the slides, combine this one to the other. Share.
Oh yeah, and if you want to do any additional reading in the GitHub repository, there's a section at the end where I've linked a bunch of additional resources. Some of them are short, and then include some videos too that you can look at if you want to read further. Thank you. Thank you everybody for attending. All right.
All right.
Right, so I'm going to on the meetup, I'm just going to send a link to the slide so that everyone that RSVP'd can get a copy and stuff. So yeah, I'm just going to stop recording now.